Hi there. For this video, we'll be discussing about the absolute value inequalities. Now that we are done in discussing polynomial inequalities as well as rational inequalities, the next basic inequality that we have is the absolute value inequality. So to solve this, note that in absolute value inequalities, we'll have two cases. That is either absolute value of A is greater than B, or it is less than B. If it is greater than B, note that we can write this one as A is greater than B, or A is less than negative. And for the other case, note that we can write this as we can write this as A is between negative B to B. So basically what we are doing here is we're trying to remove this absolute values out here in order to convert the inequality to something that we know, either polynomial or rational. And also, take note that if we have an equal to out here, then we simply add an equal to as well in the converted form. So, these two are the things that we need to remember and recall when solving absolute value inequalities. So let's try this one out in an example. Again, this one out here is of the form A, absolute value of A is greater than B. So given that, we know that this can be written as A is greater than B, or A is less than negative 2. So we'll take note of this out here in solving this problem. So we can write this as 4x minus 1 is greater than 2, or 4x minus 1 is less than negative 2. Now we'll solve each of these inequalities, the splitted one by one. So solving for x out here, we start by moving negative 1 to the right, and so we'll have here 4x is greater than 2 plus 1 will be 3. Then we divide for both sides to obtain x is greater than 3 over 4. Similarly, for the next one, we start by moving negative 1 to the right to obtain 4x is less than negative 2 plus 1, that would be negative 1. Then we divide for both sides to get x is less than negative 1 over 4. And bringing this one down, this out here is already our final answer. Let's box that one. Oops. There. But ideally, sometimes we prefer the answer to be in an interval notation. So just take note that when we have an or out here, that simply means that we're talking about the union of two sets. So in interval notation, this is simply first, this one out here will be from negative infinity to negative 1 over 4 union this out here, that will be 3 over 4 to positive infinity. And this out here is our answer for this first example. Let's have this next example. Again, take note that this form is absolute value of A is greater than or equal to B. Again, in this case, we have greater than but with an equal sign. So we know that this would be splitted into A is greater than or equal to B, or A is less than or equal to negative. Now we solve this problem. So we'll have here, we split the absolute value into 2, so we'll have y minus 5 is greater than or equal to y plus 7 over 5, or y minus 5 is less than or equal to the negative of this one out here. So that will be negative, let's put a parenthesis here, y plus 7 over 5. And we solve these inequalities one by one. So multiplying 5 both sides to eliminate the denominator. This will be, on the left we'll have 5y minus 25 is greater than or equal to y plus 7. Now, moving y to the left and negative 25 to the right, we'll have here 4y is greater than or equal to 25 plus 7. That will be 32. Lastly, we divide for both sides to obtain y is greater than or equal to 8. For this next one, similarly, we multiply 5 both sides to eliminate the denominator. So we'll have here, let's move this a bit to the right to avoid confusion. There. So we'll have here 5y minus 25 is less than or equal to, let's also distribute already the negative sign out here. It's less than or equal to negative y minus 7. There. Then we move negative y to the left and negative 25 to the right to obtain 6y is less than or equal to 25 minus 7, that would be 18. Divide 6 both sides and we get y is less than or equal to 3. Bringing down the or out here. Let's put this one out here, and this out here is already our answer for this problem. But again, in interval notation, we can write this as, this one out here would be negative infinity to 3 with a bracket since we're dealing with equal to out here, union, this one, that would be 8 to positive infinity. So this is the answer for this problem. Let's have this third example. Now in this case, our form is absolute value of A is less than B. So if we recall from above, we can express this as A is between negative b to, and applying this now to our given, then we'll have here, we'll write this one as 2w minus 5 is between negative 3 to 3. There. And we can actually solve this simultaneously or at the same time. So what we can do is we can add 5 in every part of the inequality, since we want to remove this negative 5 out here. So we'll obtain here negative 3 plus 5 is 2. Then in the middle we'll have 2w. And lastly, on the rightmost side, 3 plus 5 is 8. Lastly, we divide 2 in every part of the inequality to eliminate the 2 out here. And we'll get here 1 w out here and 4. So this out here is our answer for this problem. In interval notation, we can express this as 1, 2, 4. Like that. It's very straightforward and simple in this one, since we solve the inequality at the same time. Now what if we have this? There. For our last example, we'll have this problem. So similarly, it is of the form absolute value of A is less than or equal to, this time, B. So since we have an equal to, then we'll simply have A is from negative B to B. Oops, there. So we apply this idea on our problem. So we can write this one as 3z plus a is from the negative of 2z plus 2. So that will just be negative 2z minus 2 up until the positive version. So that will be just 2z plus 2. Now from here, observe that we can't really solve this simultaneously, since we cannot try to subtract 8 out here to eliminate this. But in terms of eliminating the 3, we can't really remove this out here, since the z's on the right and the left are different in signs. I hope that was clear. But in this types of problem, what we do instead is we split this as well into this one and into this one. Oops. Into this one out here. So we'll do just that. So we'll have this one in the first, we'll have here negative 2z minus 2 is less than or equal to 3z plus 8. And on the right, we'll have here 3z plus 8 is less than or equal to 2z plus 2. But just take note that since we're actually solving this simultaneously, then instead of or, we consider and in this case. That means that upon getting the answer, instead of getting the union, we'll get the intersection, since we are solving this simultaneously in the first place. So we have here on the left, we move 3z on the left and negative 2 to the right to obtain negative 5z is less than or equal to 10. Divide -5 both sides, and we get z is greater than or equal to -2. So take note here that the signs reversed when we are multiplying or dividing by a negative factor. See if that is correct. Yep. And for the right side, we'll have here, so we start by moving 2z to the left and 8 to the right to obtain z is less than or equal to 2 minus 8. That would be -6. Z. Yep, -8 is 2 there. So now we have two values out here. The problem is, how do we get the intersection? So let's try to clear out some space first. Oops. Oops. Forgot the 6 there. My bad. Now in here, what we do is we draw a number line. There. And let's say if 0 is out here, then probably -2 is around here, and -6 is around here. Yep. Now sketching this one, then we know that z is greater than or equal to -2 would be represented by this out here. And for the next one, z is less than or equal to -6 would be represented by this one out here. Now in here, the problem is we need to get the intersection. But unfortunately, clearly, there isn't really any intersection out here. Since if we compare these lines, they don't connect. Which means that there are no values of z that satisfy this inequality. Therefore, the answer for this one is an empty set. Or z is in the empty set, since there are no values in z that satisfy this inequality. And you could actually verify that yourself by trying to plug in some values out here. Now before I end this one, here are two exercises that you can work on. So for this one, first we have the absolute value of x squared minus 5x is greater than 6. So as a hint out here, what you would do is you would first apply the absolute value case 1, which is this one out here. So we know that this will become a is greater than b, or a is less than -b. Then after that, you'll apply, since this time we have a square out here, then you'll apply the methods in the quadratic inequality. So you may refer to my video if you're kind of lost in how to solve that one. And for the next example, we have here the absolute value of 3h is less than or equal to the absolute value of h minus 8. Now for this case, you might be wondering, since we didn't really have any case wherein the absolute value out here are both present. What you can do here is you can move one of this in one side and take note that the absolute value of a over the absolute value of b is equal to the absolute value of a over b. So something like this. And you can apply the cases that we have in this video. So that's it. I hope you enjoyed this one, and yeah, feel free to comment down below any comments, suggestions, and even corrections if there are any in this one. So that's it, and that is all for this video.